Hey guys, welcome back to part 2 of server hardware. So let's continue. So let's look at central processing units for servers. So the central processing unit is basically the brain of the server, and it comes on a chip. Of course, to handle more intensive workloads, having more brains helps. The first version of a CPU is referred to as step 0, and as they release more and more, it will be step 1 and then step 2. Adding more horsepower to a server is called scaling up a server, while adding additional servers to handle a workload is called scaling out. CPU architecture. Although most modern CPUs have 64-bit data paths, you may come across older hardware that may be 32-bit, although it's becoming less common. And for example, the last one that we've seen, 2012 R2, was 32-bit, and it only supported 4 gigabytes of RAM, which is not too helpful. Nowadays, RAM is important on servers. You're going to need a lot more. 64-bit machines can handle 16 exabytes. That's a lot. Okay. Modern mobile devices use the ARM processor, which is referred to Advanced RISC Machine. I can think of things like Apple iPods, iPads, iPhones, something like a Raspberry Pi probably uses that really small processor. Also, like Microsoft Surface uses that. You also want to be mindful of virtualization. Make sure that your chips support Hyper-V, VMware vSphere, or something like that. CPUs must have hardware virtualization support enabled in the BIOS, and you have to turn that on. AMD virtualization is called AMDV, and then Intel uses Intel Virtualization Technology, or IVT. Okay. So we did talk about the bus and how important the bus is on the server. How do we move data around, get it from a component to the chip, to the memory, and vice versa, back and forth? That's pretty important. Okay, waiting for the bus. Buses move data among the various components within a computing device. So every server motherboard always includes several buses, such as a PCIe expansion card bus, and the main system bus. Bus speed, which is usually megahertz or even gigahertz, is different from the internal CPU speed, and that determines on how quickly things get done. Okay, let's talk about the cache. Caching is really important. CPUs have small amounts of high-speed memory, or we call them caches, to speed up the execution of instructions. Well, to say it differently, we can increase the hit rate. The hit rate indicates that when the CPU needs instruction or data, it was received from the cache, referred to as a hit, instead of from a slower location, such as finding the data in the L1, the L2, or the L3. The L4 is the slowest and largest. L1 is the fastest, but less common. So L4 uses main system memory. The other ones are dedicated. The reason L1 cache, for example, is faster is because it uses static RAM, or SRAM, as opposed to dynamic RAM, or even synchronous dynamic RAM. So the static RAM uses transistors to retain the data and sends it, and it's much faster. The CPU cache size and the differences between the CPU and the motherboard. Keep in mind that L3 and L4 cache is memory used by all CPU cores for the CPU chip. There will be different algorithms that the computer uses to complete a task. A common one will be like the least recently used, or the LRU algorithm. So when something's not needed anymore on the cache, then it will remove that item and proceed to move the instructions to the next one. So that just gets rid of the least important thing or the oldest thing. opposite of that would be a MRU algorithm, or most recently used, if you want to free up what was recently used instead of what was old. But who would want to do that? I guess specific servers may need specific things. You could customize that. GPUs, graphical processing unit. Actually, Daniel's book missed a pretty important topic, which is AI. Artificial intelligence is using GPUs to help streamline and parallel process things faster. It uses the CPU, it uses GPU, and it's able to parallel process and get things done quicker. And I think as we head towards the future and AI era grows more and more, yeah, that's going to be more common. That's going to be more practical. You're going to need to add graphic cards to an AI server or to something that needs graphics. So if it's not just a machine like an engineering software machine that maybe needs a graphics card to load the software or something, then it may be an AI server that needs to crunch these crazy numbers, and it will use every resource it has. Okay. Memory. Random access memory is the electronic volatile memory used by running programs. It needs electricity to retain data, unlike disk storage devices. Servers can accommodate different amounts and types of RAM, and motherboards can have specific memory module placement rules. Server motherboards normally require memory chips to be installed in pairs for efficient use by a CPU socket. Pairing along with other memory requirements can differ from one motherboard to the next, so make sure to read your motherboard documentation. Let's talk about memory timing. There's schemes such as double pumping, which can transmit data on the rise and fall of a clocking. So if the clocks match, you can actually process things quicker. So this means your data transfer rate is effectively doubled. You can think of electronic memory being organized into two rows and columns. The trick is getting data in or out of the memory addresses as quickly as possible. Factors that influence this are how long it takes to read a memory column, how long it takes to select a memory row, and how long it takes to read the data that it needs to read. Okay, other important things. Error correcting code, or ECC. ECC memory is specialized for servers, and if there's ever an error or a problem, these memory modules will fix the errors on the fly. So how that happens is this type of memory chip has added capability of detecting and fixing errors at the bit level. So if it's a 0 or a 1 that's not correct, it will correct it. It does this by using an extra bit of information, which is called the parity bit, for each group of memory bits. Although most non-ECC modules can detect memory errors, they don't do anything about it. But in a more serious environment, you got a serious server, maybe in a financial world, you have customers logging in, banks that need to be up all the time. You can't have any errors, can't have any crashes, can't have any instability. So you would need to go into the BIOS, enable this ECC feature, and make sure your ECC memory is installed. Okay, peripherals and the bus. Well, we talked about the bus a little bit already. Motherboards and expansion cards need a way to move data around, and this is where the bus comes in. Think of computer buses like a real bus, which moves people around using roads. A computer moves data bits around the system using buses. There are many different types of buses, and some motherboards accommodate multiple buses. The buses we discuss here are for expansion cards plugged into expansion slots. For example, we have PCI, PCIX, and PCIe. Although the former two are quite old, you're going to see PCIe more often. We have the data transfer rates on the slide here. So if you're on a PCIe 3.0 with channels X16, yeah, it's pretty fast. So those are good transfer rates you're going to get on the bus for your peripherals. That's good enough for me. I don't need to like go into extreme detail. Okay, NICs, network interface cards. Very important that your server has multiple NICs. In case one NIC dies, well, then the server goes down. But if you have a backup, it keeps running. Also, reasons why you'd want multiple NICs or even a virtual NIC is to isolate, to subnet, maybe to VLAN, or add an adapter onto some sort of network that normally people couldn't. So if you have this functionality, then you can put computers between subnets or between VLANs and have them on multiple networks. That's just from my experience. So yeah, be mindful of speed, be mindful of distance. You need certain kinds of cables, you need certain kinds of ports. Pretty common nowadays that you want to upgrade to 10 gigabits per second on your NIC. Yep, we already talked about VLAN, virtual networking, those things, which you can do with another NIC. Okay. Oops, I skipped a slide. Sorry. Storage. Storage is sometimes embedded on server motherboards, such as we talked about a blade server that's embedded on there. Other times servers have local disks available, and there's also a possibility that your server could reach out to a network attached storage to get its storage, or use a SAN, a serial area network. Sorry, storage area network. So there's different ways you can access data on a server. You can slice, you can carve, you can have a physical disk partition, you can use it over a hypervisor, you can use storage accessible through the hypervisor on a SAN, on a NAS, you can use virtual hard disk, you can do a VHD file, a lot of different ways you can configure storage for your server. RAID controllers. RAID is important. We need redundancy. What does RAID stand for? Redundant array of inexpensive disks, something like that. Okay, so you can have a software RAID, you can have a hardware RAID. Depending on what you want, you probably should use a hardware RAID. Why not? If you've got the money and the hardware to do it, that's probably the best way to go. Most server motherboards include an integrated RAID controller that connects to multiple disks on your motherboard. RAID controllers have their own firmware, has its own BIOS, it boots up, it checks things. Disk arrays can have hot spares. You can plug a disk into the array. When it crashes, you put in a new one and it will rebuild it on the fly. This is called hot swapping. Pretty important that you can hot swap your hard drives because, well, things happen. Hard drives go bad, data gets corrupted. Okay, battery-backed write caching. That's pretty important for you to know as a server technician. So let's say your server lost power. There's still a battery in your RAID controller. It's still caching the ones and zeros. Even if your server turned off, the next time it turns on, it will write to those disks and make sure your data is correct. Okay, software RAID we didn't talk about much. Your OS, server OS version will have some sort of backup or some sort of software that you can use to configure your disks. Or you can use a third party. USB, really in the Server Plus we're studying USB? Yeah, we are. You're supposed to know USB 1.0, 2.0, 3.0, and 4.0. It's a serial bus. You need to know the differences in the hardware peripherals. You need to know that serial. You probably already know keyboard, video, mouse. Those things can be USB. I guess I would focus on the speeds then, and focus that you can use a KVM via USB nowadays. But other than that, what would they test you on? Okay, power. Power is a big one. Power from the smallest server in an enthusiast basement to thousands of servers in a data center in the cloud. Power is important. You need to understand power. Server virtualization reduces power consumption. You can put multiple virtual servers into one physical server. Power connections like plugs and sockets come in a variety of standards. The standard 2-prong or 3-prong ground plug used in North America, we use the NEMA, or National Electronic Manufacturers Association. So you've got NEMA plugs, you've got Edison's that are 3-prong. You have industrial grade equipment that has a twist and lock to make sure that nothing actually moves out of the wall, keeps it safe. You will need to know voltage, how to convert voltage, understanding voltage, amps, kilowatt hours, alternating current, direct current. Those are things that we should have studied in the A+. You should know that North America uses like 120 volt. A lot of Europe uses like 240 volt. You will need to know the different power connectors for different hardware, the voltage regulator like +5 or +12 volt, and what kind of equipment need that, CPU, hard drive, etc., etc. ESD, or electrostatic discharge, which will be your enemy. You need to make sure you ground yourself if you work on a server. You have an electronic charge on you and it needs to match. You can always ground yourself by touching the chassis of the server or use equipment like a mat, shoes, a wrist strap. Okay, here's an example. I'm going to turn this into a PBQ in the future. But yeah, you'll need to know power. You'll need to know how to do a formula, how to calculate your servers, your power consumption, get the load on a UPS, make sure your clients and customers are happy. So I'm going to give you this example. So one server, I'll give you the watts. 2,700 watts is what it's pulling. So we're going to divide that by 0.9. That is the volts. So now we know one server's 3,000 volts. I'm going to give you 3 servers to calculate the load on in the next slide. So just remember that 1 is 3,000. So let's take this formula 1.3. So if I take that single server, that's 3,000, multiply it by 1.3, now my kilo voltage or kilowatt hour, I forgot what it's called. Kilo voltage is now 3,900 times 3. So about 12,000 will be your answer for your kilo voltage. So we'll have a PBQ that is similar to that. You'll need to do some math. You'll need to calculate loads, spikes, surges, get ready for power interruptions with the UPS. Okay, environmental controls. Server rooms are very particular. We need to be very careful. Temperature is really important. There is a range of temperatures which are healthy. I always remember like 70 to 75. This says 64 to 80. Relative humidity should be about 50%. A little bit lower, a little bit higher is fine. You should know that for fire extinguishers, the Class C is used for electrical equipment. Okay, airflow. You should know that fresh air is pulled in from an air conditioner and it goes through these servers with fans, and then the hot air from this equipment goes out. This is called the baffle. And that's it. Thanks for watching. Thank you, Daniel LaChance, for your content. And yeah, check them out if you like them. I hope you enjoyed the video. Hope you learned something new. And if you didn't, I hope you feel a little bit more confident. Check out my channel for more CompTIA content.